Okay, welcome back everyone. Nice to have us here again. So this is our second section at the Ethereum Nigeria Residency 2025. And today we have on the call with me here Mr. Atindere. He will be talking about the backend development as the backbone for building Web3 products. So I hope you're gonna have a very amazing ride here, learning as well. If you missed our first session, you can always go back to our previous video and rewatch, ask a question in the community, and we'll be happy to answer your question. So nice to have you here. Can you hear me? Can you
Yeah,
hear me?
thank you, thank
Asking.
you, thank you. Yeah, I can hear you, and can you hear me also?
You can go ahead.
Can anyone hear me?
Yeah, I can hear you.
All right, can you see my screen also? I'm sharing my screen.
Not yet. Um, you sharing your screen.
Uh, Sharing. I'll stop sharing and I'll share again. Uh, how about now? Can you see my screen now?
Yeah, yes, yes, you can.
All right, all right. So again, hi guys. I'm excited to be here. I'm excited to, have this session with you guys, and we're having this very interesting residence time out, and I'm definitely sure that since it started, it's been immensely interesting. We had the last speaker speak on how to navigate Solidity being one of the most pivotal language through which we write, smart contracts and all and all. And I believe it was based on the feedback from the listeners, the audience. I believe that was quite an interesting session. So we'll be having a very, very interesting session as well now. We want to talk about how we want to uh, merge the whole Web3 uh, space with what we have on Web2, our backend space. So we have like, excuse me, just one second. All right. So we have before us the backbone of Web3, building scalable and hybrid backend architecture. So our backend developers bridge the decentralized divide. So this is going to be quite technical, but it's also going to delve into a non-technical arm of what we're really talking about around Web3. So Web3, we know Web3 to be where we build essentially that part of the web, that version of the web that we build decentralized applications. We are able to, do stuff around the blockchain network, having controls that are much more secured rather than the regular Web 2 where controls are, easily mutable. However, while we talk so interestingly about we can get a lot of things done, there are some limitations that are that we are exposed to. There are some concerns that we are exposed to around the Web3 space that makes introduction of the whole backend architecture, the whole backend space of the Web2 side of the web quite imperative and necessary. And that is what we are talking about now, seeing how backend architectures, how backend services, how backend solutions play an intrinsic role in serving the Web3 space uh, easily and smoothly. Okay. Uh, so why should we have this conversation? We say Web3 promises decentralization, but blockchain can't do it all. Yes, blockchain cannot do it all. Of course, decentralization, the entire scope of your solution. Maybe you are trying to work in finance, DeFi, decentralized finance, or you're trying to work do some NFTs, all of those interesting stuff, hosted, served on the blockchain, right? However, when you talk about you delivering it to your customers who are not necessarily sometimes in tuned in the discrepancy between Web 2 and Web 3, how do you serve them? How do you deliver value to them? You have to be very, very careful to see that you are not just all about the whole interesting technicalities, but rather while you are handling your technicalities properly in Web3, you're able to like serve your customers well. I'm going to give us an example. So think of somebody who wants to build, say, a social network on a contract, for example. You want to build it around, say, uh, maybe one contract on EVM, for example, and you want to serve people who are familiar with the likes of Twitter, people who are familiar with the likes of TikTok, Facebook, name any social app you can think about. They want to have, why they know they are operating on a secured environment, why they know they are operating on the blockchain network. They also want to have an experience that makes it easy for them to interact with your solution. So simple subject like authentication can be really, really difficult to handle authentication can be really, really difficult to handle on chain. You want to maybe keep track of informations like using maybe the wallet address of a user to be the sole or the unique identifier. You also want to maybe track their IP addresses. You want to do some quite interesting stuff that are not necessarily things that you could host on chain. How do you get to handle all of those? How do you get to say you want to handle things like suggesting feeds based on maybe previous activity? How do you keep track of that? How do you handle all of those interesting yet extensive business logic? You really cannot necessarily host all of those on chain. So you definitely want to bring it down to the level of the Web2 system that is much more interesting and much more interactive when we talk of delivering a proper UX solution. So performance, scalability, and UX still depends on backend infrastructure. So there are many examples we can go on and on to talk about, but a perfect one is the example, a simple one of authentication that I just spoken about. In the regular Web2 space, authentication will work with, say, my username and my password, or my email and my password, or just some specific identifier. But in Web3, I just want the user with their Phantom wallet or with their Backpack wallet to be able to easily access whatever we are serving, whatever value we are serving them with. But beyond the informations that are, kept on chain, beyond, all the data, all the logic that we are keeping to sit on the blockchain, on the contract, we still have only a limited level of control as to some of the dynamics of user experience, of interactivity, of performance and scale that we can deliver just on chain. So again, it becomes imperative to consider factoring or integrating on backend services. And of course, we do have a number of backend services, backend languages. You have the likes of JavaScript through Node. You have PHP. We have Rust. We have Golang. We have Python, and quite a number of them, right? Of which every one of them are able to serve these purposes. But oftentimes in the Web3 space, when people are trying to like come down to like, some of the backend tools, people oftentimes, it's often like you often find people that adopt the Node.js, because even libraries like ETHNigeria are one of like the most used libraries in the Web3 space. Of course, it's a very robust library, as a matter of fact, and you find huge support, huge community support on JavaScript. So if you're considering languages, if you're considering tools to get put to use, you most definitely want to consider all of those languages, of which in terms of like community support, JavaScript happens to, trump many of those languages in the Web3 space. Okay, so let's talk about what really makes Web3 different. Trustless system, quite beautiful. There is the old decentralization idea. It's not a thing that just one person can just get into and alter I don't need to trust you before I can get to use it because I trust the system. It's not a thing where somebody is having to. A simple idea, a simple example. I am hosting X and Y data on a logic and data on a network. Nobody is coming to alter it. Nobody is coming to. There are protocols through which every of this data goes through, and as soon as every of this protocol approves the flow of this data or logic, it is what it is. It's not something you want to come and easily alter. So it's a trustless system, wallet-based identity. I spoke briefly on how we can get to authenticate using wallets. In the Web3 space, your wallet address is oftentimes like your primary identity. Of course, we have the likes of your public key through which you could sign transactions if you're talking about finance and all. However, your wallet is primarily your identity, so it is secured. One wallet cannot exist with two persons. Of course, you can import your address into several wallets, but it's still you who has that singular identity. On-chain execution, I've spoken about that also. The beautiful thing about blockchain is the fact that executions, logic, name it, are all decentralized. They are not things that are exposed or open to the control of threats of all of those weird stuff that we have that are eating into the Web2 space. However, it also poses some limitation. Yes, it does poses some limitation, and I spoke when I was starting. I spoke about like some small example around authentication, but they are a huge chunk. And I would actually want to talk on personal example. I have like series of stories I can tell here and there of how well Web3 becomes a little bit dependent on the back end space of Web2 to deliver optimally. You know, recently I was working on I wrote a certain contract, and then I am so I have series of transactions, like a huge chunk of transactions that have been executed by several users, of course, with through their wallets and all. It's a it's a those transactions are through some contracts. Some of them we are trying to execute them through some relayers like layer zero, like uh, what's it called? What's this contract called? Wormhole. So we needed to also put some interesting and juicy feature to our solution. Features like, being able to track points, being able to like give boosts. So we are saying if you do 4 transactions, you have say 10 points, and at certain interval, anyone who has X points is able to get so and so bonus on their next transaction. It was quite an interesting body of logic, but we really could not put all of this on chain. At best, we're able to just, you know, get through with your wallet address, generate an account ID, execute a transaction. We have access to the transaction hash, we have access to the account, we have access to, of course, your wallet information, which is essentially your identity. And we put all of this together on chain. But now the question is, how do we don't even know which wallet you are delivering from? For example, we want to say if you are executing your transaction from Phantom Wallet, we want to give you a 30% boost. If you're executing your transaction from Backpack, we want to give you a 20% boost. If you're executing your transaction from maybe Haha Wallet or any wallet, we have a number of them, we want to give you X amount of boost. We don't have the control to do all of this because number one, we don't even know which wallet you are using on chain. At best, we know your wallet ID, which can be imported into any wallet merchant, of course. So that is where backend development plays an intrinsic and an integral role. So what did I do? Every of the data that we hosted on the subgraph, it's been on and on like that. We had like how hundreds of thousands of transactions already sitting there. So the question was, how are we going to approach this? So I I pulled all the transaction information from the subgraph into a Postgres database, right? which is a database system, a relational database system. I brought that, and then I started like harmonizing every of the data. So there are some wallets that could have as much as 10 transactions or more on different rows. So I harmonized the data at first. So we had we had those transactions defined already with the transaction hash. We had the amount. We had the pool ID to tell us which asset was actually traded. It's actually a borrow and earn solution. So I was able to, so we had like some flags from the chain that is able to tell us if it is a borrow transaction or a loan or a end transaction. So we put all of those together, and on our backend solution, where I wrote some queues that would pick each of those data, and then we were creating. So we had like, of course, we had some scripts put together to do all of those sorting to check, okay, if the transaction is if it is if you are trading, say USDT, for example, this is the percentage that we want to allot as a boost, and this is the number of points we want to calculate for each. For example, if you are trading 10 token of USDT, we probably want to give you like 20%. So for 10 token, that means you are getting 2 points. So think of it that way. So we just had quite an interesting logic, right? We had it hosted, and we had like these queues, pull it. It ran for a couple of days, right? We had this queue, pull it. The queue, of course, we had workers from Redis picking those queues, executing the jobs independently. And we had like that thing scale for a number of days, after which we had it ingrained into our system fully. After we had it ingrained into our system fully, users started having like points of transactions that they executed a long while ago. We also introduced that, okay, now let's make it possible for us to track the wallet the user is working with, if it is a phantom wallet, because we're partnering with some of these wallet guys. So we're trying to like promote those wallets being used to execute those transactions. So we went that route, and being that now we have our backend system interacting with the solution directly from the front end, we were able to keep track of those so when you connect your wallet, we collect those information of your wallet type and the wallet address, of course, which we do have before. Then we just mutate your record on our DB to say, okay, this user last transaction is from Haha Wallet, or is from Phantom Wallet, or is from MetaMask, and then through it we're able to like give certain boosts, because we wanted to handle some promotional logic within our solution. Every of this interesting stuff could only happen easily because of a backend system that is off chain, right? Of course, our interesting business logic of the borrow, of the hand, we could make some loans via some collateral, interesting stuff which I will not want to delve into because of time. We had all of those sitting on chain, definitely. But many miscellaneous logic, business requirements. Okay, if we're partnering with these guys, we want to be able to promote whatever we are partnering with on our system. If you are using X token, because although we are partnering with some of the custodian of this token, we want to be able to like give some boost. So that if you are trading this particular token, if you are staking this, for example, on this solution, let's say we are building a system of where you swap or you stake and all. I want to say, okay, if you are staking this particular token, we are giving you X kind of boost, X kind of. So all of this only became possible when we introduced like a full-on scale backend side of things. It's actually run like a microservice, but it was fully important to the operation of our company. It was fully helpful in trying to like get our partners on board, trying to promote them, and even trying to giving our users seamless experience on the app. So while it is on chain, while it is Web3, backend has a very big role to play. It is more like the backbone of delivering Web3 services even to your users. So I've written it here already. No complex off-chain logic. You really cannot bring some of the off-chain logic that we have on say Node.js, for example. You can't bring many of those logic to the chains. Solidity has its scope. solidity, which was spoken about in the last session, quite interesting. It has a scope. You are only able to tackle, blockchain concentrated logic, blockchain. If you are doing NFT, if you are trying to like mine, if you're trying to mine some, say some NFT, if you're trying to do some spotlight thingy, if you're trying to like maybe host some entertainment logic, whatever, you could do all of those, like the transactions, the back and forth of it sitting on chain could stay on chain, of course. But when you're trying to delve in extensively into interesting stuff that concerns your users, delivering primary and user interesting experience, you definitely want to get all of this posted and offloaded down to a backend microservice, or just a backend arm of your solution that is able to deliver at scale for that purpose. So, of course, poor UX without a backend. If you are serving people who are pros in the Web3 space, of course, you might not need to explain some things, but there are some level of complexity you want to offload down to the backend system so that you're able to like capture, process, and deliver those data in a much more seamless and cleaner way. But if you are dealing with people who are just regular users or just newbies to Web3, and you're trying to explain some things, you're trying to deliver some value, if the experience becomes, it's just a normal human psychology thing. When the experience is not easily relatable in the first 10 seconds of getting on the app, it becomes it's very likely that people will begin to like, what, I need to find an alternative to this. This is becoming more difficult to interact with. So you have a poor UX delivery to your users when you are not considering this backbone of Web3. So you want to build a scalable, you want to build a hybrid solution, Web3 solution without backend architectures, man, you are in for a long thing. All right, let's check the next slide. So backend's role in the Web3 stack, smart contract plus backend, you have functional decentralized application. And that's for a fact. That's for a fact. I can even overemphasize that. I've spoken lightly on some of these things. Event indexing, wallet auth, off-chain computation, API integrations. Think of it this way. Say you are, let me think of a perfect example. So let's say I want to okay, good. Say I want to build just some small tool for users to be able to stake maybe USDT to uh, maybe to Ethereum on maybe Arbitrum, for example, or any other contract. I that's an interesting thing to do, right? So really, what the user really wants to do is to say, when I click A and I click B and I click C, I want to see that so and so token has been staked. That's all the user is interested in, right? And that's true, but that's the best you'll be able to deliver. But say you want to now scale to the point of saying, all right, I want the dashboard to be a little more customizable so that I'm able to even give it to some people that are not necessarily merchants to be able to customize it, put their own logo, put their own name. So it doesn't even look like I built it. So anybody can take that tool, just maybe pay me X amount of money and say they take the tool, they're able to like deliver to any of their clients to say, or their customers to say, you could stake X and Y, and it will have their logo, it will have their name, you can't do all of that just by integrating with on-chain logic alone. Your on-chain logic at best is going to help you with your contract, which in that situation, you're not even writing the contract yourself. The contract interaction has already been provided to you by the contract you're working on, the blockchain contract you're working with. So at that point, you probably want to, your integration with that contract comes or boils down back to building a full-on backend system. Number one, you get the APIs, of course. You want to use tools like ether.js to interact with their functions for staking. Okay, you want to know, okay, if I'm working with this particular token, maybe USDT, okay, the question is on Arbitrum, what is the token address? All of this logic you definitely are going to have to write on a backend architecture, on a backend solution. you can only bake all of that there. So while it is a lot of interaction happening on the contract, you have no business with the contract. Your only interface of interaction in that contract comes down back to the operation of your backend infrastructure, your backend solution. So even back to how you want to the whole dynamism, putting it in colors, making it fancy, a customizable dashboard, and that is just an idea that is just top of my head. There are numerous examples that can like that this can be factored into. It still goes back to pulling up maybe a table in your database to say, okay, this table I want you to keep customizations of record, the colors, the logos, you want to, all of those interesting stuff. You still have to write your queries, you still have to write endpoints, APIs that you deliver to that you put to the integrate in the front end. Front end integrates to so the front end is speaking to the back end is speaking to the contract, and on the front end you are able to deliver a full-on functional decentralized application to your user, to your clients, to your customers. So over and over again, it remains the fact remains clear that to deliver a fully functional application in Web3 to your user, you want to consider a scalable backend architecture, a scalable backend infrastructure to help put this into perfect play. Okay, I think I have about a few minutes to go. So bridging Web 2 and Web 3, not everything belongs on chain. I spoke about that already. Backend offers performance and flexibility, and that is for a fact. Talking about performance and flexibility, I'll speak about the example I gave the other time about I was trying to pull some transactions on the subgraph and get it to, use it to compute some points, some also to like define rankings for users for business purposes, of course. I really would not be able to get about 300 transactions, 300 and something transactions. I have to put it on a queue. I had to put it on a queue, get workers that could, run that queue at certain intervals, pick every of those like instances of transactions and execute a job on its behalf, on the behalf of the user that transaction belongs to. That performance is only possible on the backend infrastructure. Like that's a whole world on its own. That the whole integration, the whole operation, it's only possible on that front. If you are trying to limit the scope of everything to the contract alone, we definitely would not be able to get to do what we did at that time. Not possible. Not possible. So while Web3 poses its interesting advantage, the cases like performance, flexibility, user experience, interoperability with other systems, integration with other sources, feeding data from other sources to do, a lot of stuff would not be possible. So a backend infrastructure being integrated, being breached with your Web3 system offers performance and of course flexibility. Typical stacks, smart contracts, been integrated with backend system. I spoke about several languages. There are a lot of them, a lot of them. But Node.js, Go are examples here. We have Rust, we have C Sharp, we have PHP, and many of these languages they have frameworks on which they are integrated, on which they have made a lot of things much more easier. For Node.js, you find the likes of Express.js, you find the likes of Nest.js, which is much more structured. For the likes of Laravel, the likes of Coordinator, Laravel on PHP rather, right? And for like storages, we have IPFS, we have DBs. I spoke about Postgres DBs the other time. We have other DBs like the MySQL one. There are some NoSQL DBs also, depending on your business logic. I'm not a fan of NoSQL DBs, so pardon my bias. Anyways, and then your front end. So your front end is where you are delivering the value to the user. Your front end could be a mobile application. Your front end could be something that is accessible via URL on the browser. It could be anything. Okay. So yes. So essentially, those are the ways we get to bridge Web 2 and Web 3 space together. And we have some real world example I factored in here. I spoke about time elapsed implementation with relayers, retry mechanism, and prepare transaction. maybe I should spend the next couple of minutes speaking on some of these examples. I've cited some real life hands-on examples or experiences that I have had, and these are also some of them. Time elapsed implementation with relayers, performing some transactions on some contracts that are probably going to take, say, uh, 10 minutes or 5 minutes, depending on the peculiarity of the transaction you are executing and the contract on which you are executing it. You sometimes the relayer is able to tell you that, hey, it's going to take me about 5 minutes or 600 seconds to execute this particular transaction. But then you need to be able to give your user a perfect experience. For instance, you maybe under the hood, you want to keep checking uh, that particular relayer after that stipulated time frame. So if the relayer says it's going to take it 10 minutes to execute a transaction, I want to be able to save it somewhere, maybe on a queue, maybe using like a Redis caching mechanism to cache that information to say, after this transaction, cache this information temporarily, 10 minutes. Then after 10 minutes, go back to check the relayer for the status of this transaction. Of course, after the initialization of the transaction, you have the transaction hash, you have every necessary information you need to check that status, and then you are going back to the relayer after that stipulated minutes. Why? You have a scalable system that has been built to do all of those activities. Your relayer cannot do all of that. At best, it's been able to give an estimate. Then, after your radio system it waits for that duration, after that duration elapses, it triggers the relayer to say, tell me the status of this particular transaction. If it is successful, then you can build maybe a retry mechanism. If it is not successful, make the stipulated time go by 5 and check it. Maybe that should be 2 minutes in this case, and then check it after 2 minutes again, and then after another 2 minutes. And if it is then not successful after a total of about 14 minutes, when it has estimated 10 minutes, depending on the dynamics of your business logic, you want to say, you know what, terminate this transaction or declare this transaction unsuccessful. All of those are only possible through a backend system. So, for example, maybe if the transaction is successful, I want to be able to tell my user that, oh, that transaction was successful. The user shouldn't have to refresh. And then I can say, okay, I want to integrate maybe a push notification. I want to use things systems like maybe Pusher to say, or maybe a Firebase cloud messaging system, depending on the logic of your business logic, just to say, okay, the moment you find this transaction, a lot of background processes running. The moment you find this transaction, I want you to make a call immediately and directly to this server, maybe the FCM server, Firebase Cloud Messaging server, or maybe a pusher or a WebSocket service essentially. Push it to this, and then the user, without doing anything, just found transaction executed. And yeah, oh, voila, it's all done. And then they click, they can see history, the details of that transaction. All of this interesting user experience really cannot happen without you integrating in carefully on a scalable backend infrastructure. The same with a retry mechanism and prepare transaction. Say in the case of a transaction failing, you want the user to be able to retry it. Maybe you are doing a transaction that is going from maybe USDT to Ethereum to WETH, and then maybe from WETH, you then want to maybe stake it to another. There are a lot of things that we do in this Web3 space that are quite interesting. And then you are doing all of this, maybe about 4 chains of transaction. They're happening on different contracts. If not different contracts, they're happening on different protocols, at least. You really cannot track all of those things because Uniswap doesn't know what's happening with some other guy and some other guy and some other guy, if you know what I'm talking about. So you probably want to, like, for every of this activity, you want to keep a track, a log somewhere in your backend. So maybe when it fails at stage 2 or stage 3, the user just needs to click retry. The user doesn't really know what's happening on that dude. The user doesn't know that there are about 10,000 activities happening on that dude because you built a scalable, interesting backend infrastructure. All they need to do is click a button. Meanwhile, you are doing so many things behind you by knowing which part of the transaction failed. Maybe at the point of staking, maybe you are doing something like staking, swapping, and bridging. And then at the point of it, or maybe let's put it this way, bridging, swapping, and staking. Let's use that chain. So maybe at the point of staking, it failed, or maybe at the point of swapping, it failed. When the user clicks retry, you don't need to rebridge. You've breached already. You've breached from a particular asset family to another asset family. The moment your user is clicking retry, you know you want to stake immediately. You want to swap immediately, and of course after swapping, then stake. So things like that, you're only able to keep all of those activity. You're only able to capture all of those details, all of those information in a fully structured backend system that gives a seamless experience to your users. Save for this, we're probably going to be building craps on our Web3 spaces, and I'm sure we don't want to build Web3 in a crappy format. So this brings me to the end of this interesting session, where I say, yeah, decentralization isn't the magic, it's engineered, and the backend is the engine room. So thanks, guys. This brings me to the end of my session. So I want to hear questions rolling on the, all of those interesting stuff. Thank you, thank you, thank you.
Hi, Mr. King. Thank you so much for the class. I've learned so much about backend. I think by now I'll be able to talk more with my dev. So what are we using? What's the best solution for this process? When you are shipping on chain and everything. Thank you so much for the
Sure,
class.
sure, sure.
So if there's any questions, please let's
My
drop
pleasure.
it, and yeah, they can also drop it in this
Guys, bring it on,
group.
bring it on, bring it on, bring it on, bring it on, bring the questions rolling in.
I know the energy. Bring it on. We are here to answer your questions. So thank you so much for having our time this evening, and
Bring
we
it
are
on,
so
bring it on. Let
grateful.
me see your doubts.
So I'm very sure that there will be a lot of questions that they will possibly be dropping in the group or reaching out, and we always get them across to you so that there will be more clarity to what they have in mind. So I don't know, maybe Mr. Enoch has anything um, to share with us. So, but before I hand over to Mr. Enoch, tomorrow is we are celebrating. We are joining the Ethereum celebration of 10 years, and yeah, so Ethereum Nigeria we also be joining the celebration, and we want to say let's just put it out there. Let's celebrate with Ethereum. It's been 10 years of of powerful mission to bring everyone on chain, and it has been
Right,
amazing.
right, right, right.
It's been amazing. It's been amazing. So it's already flying everywhere on Twitter today, and I just have to join that conversation. So that's it for tomorrow. We are going out there full blown celebrating Ethereum, and our next workshop will be tomorrow evening. That will be communicated to us or on Thursday. So yeah, thank you so much, Mr. Ake, for your time. We are so grateful for that. So
It's
do
my
have a
pleasure.
very
It's my
nice
pleasure. It's
day.
my pleasure.
Thank you. Thank you.
Thank you. Bye.